morning students, welcome to video lectures on chemistry. So in our last class we completed the compounds of 17th group and also the elements of 17th group. So elements of 17th group. So what are the elements present in 17th group or 7th A group? So these are fluorine, chlorine, bromine, iodine and astatine. So these are the 5 elements present in 17th group, or simply these are 7th A group, that is halogen family or simply fluorine family. So we discussed all the properties of halogens and also atomic numbers, electronic configuration and physical properties. So now today I am going to explain the compounds of 17th group. So what are the compounds? Compounds of 17th group. So the important compounds of 17th group elements are interhalogens. So this is important essay question in this chapter, interhalogens. So these are the compounds of halogen. Compounds of halogen, that is nothing but interhalogens. So there exists a bond between 2 halogens or 3 halogens. So that is nothing but the compounds of halogen, the compounds of halogen with another halogen, is known as interhalogen compound. So the compound containing one halogen, so it is bonded with another halogen. So there exists a bonds between 2 or 3 halogens, then it is nothing but interhalogen. So these are the compounds of halogen with another halogen. So halogens nearly forms 11 interhalogens among themselves. So there are nearly 11 important interhalogen compounds are there. So these are due to formation of bond between halogens. So among the halogens there exists a bond between any 2 halogens forms nearly 11 interhalogens. So the formation of interhalogen is mainly due to, so what is the reason for formation of interhalogens? So there are 2 reasons for the formation of interhalogen. So first reason is halogens having highest electronegativity. So this is the first reason. No element having greater electronegativity than halogens. So halogens are only having NH2NP5 configuration. So all these are always having a tendency to gain of 1 electron. So whenever halogen gain 1 electron, then it becomes NH2NP6 configuration, that is a stable inert gas configuration. So when an halogen attract 1 electron, it becomes NH2NP6, that is it is a noble gas configuration. So these are more stable. That is why halogens are always having high electronegativity. So these always attract electron towards itself. Therefore, these forms interhalogens. So first reason is these are having highest electronegativity, and the second reason is, so there is a large size difference. There is a large size difference between the halogens. So these are the main reasons. So here fluorine is very small size, whereas iodine is very large size. Therefore, from top to bottom its size increases. If an halogen is bonded with another halogen, it forms a interhalogen in which the difference between size of the 2 atoms or elements is very high. So that is the reason for the formation of interhalogen compound. So first reason is highest electronegativity, and the second one is large size difference between the halogens. So due to these reasons, halogens forms nearly 11 interhalogens. These are further classified into 4 types. These are explained by 4 times. So here first one is AX type. interhalogen having AX. A is nothing but halogen again with another halogen X. If suppose there is only two halogens, so one halogen with another halogen, then it is nothing but AX type. So here the examples for AX type interhalogens are, so first one is CLF, that is chlorine with fluorine, and the second one is ClBr, and third one is BrCl, and fourth one is IBr, and last one is ICl. So there are CLF, CLBr, BrCl, so both are equal, either CRBr or CLBr. So one more, it is BRF, BRF. So right, so BRF, IBr and also ICl. So here there are totally 5 interhalogens having a AX type formula. So one halogen with another halogen, so CLF, chlorine with fluorine, similarly iodine with chlorine. So totally there are 5 under the heading of AX type. And the second classification is AX3 type. AX3 type interhalogens. So here the example for AX3 type is CLF3, BRF3 and IF3. So there are 3 interhalogen compounds having AX3 type interhalogens, and then AX5 type. So this is the third category having a general formula AX type. Therefore one halogen with 5 different halogens. So A is one type of halogen and X is another type of halogen. So whenever one type of halogen is bonded with 5 different types of halogens, that is X, then it gives AX type interhalogen. So the example for AX type halogens are BRF5 as well as IF5. So both iodine as well as bromine forms AX type, AX5 type interhalogen. And last one is AX7 type. AX7 type. So here one and only example for this type is IF7. Iodine forms up to 7 coordination number. So it is having 7 bonds with the fluorine. Therefore it is the interhalogen having a AX7 type. So totally 5 plus 3 plus 2 and it is equal to 1. So totally 11. So these are the important interhalogens among the halogen compounds. So one halogen bonded with another halogen. So there exist number of interhalogen compounds in which AX, AX3, AX5 and AX7 are the classification of interhalogens. So now, so what is the characteristic properties of interhalogens or important features? Important features of interhalogen compounds. So important characteristic properties of interhalogen compounds. So first one. So first one is no interhalogen compound contain, no interhalogens contains more than 2 halogens. So look at the examples. Every time A is bonded with X type, either AX or AX3 or AX5 or AX7. So here only, so there is an involvement of 2 halogens only. So that is why, so first characteristic property is no interhalogen contains more than 2 halogens. So it should contain only 2 halogens. So up to 2 halogens only. So that is the first property. And the second one. So in interhalogen compounds, fluorine does not act as a central metal. Fluorine does not act as a central metal. If suppose ClF. So here central atom is always chlorine but not fluorine. Why? So if it is central metal atom, then it becomes F plus as well as Cl minus. But this is wrong. Fluorine is always having a tendency to gain of electrons. It does not having any tendency to loss of electron. It means fluorine never behaves as a F minus, F plus. So it is always F minus, that is nothing but here F minus as well as Cl plus. It means one electron is transferred from chlorine to fluorine. One electron is transferred from chlorine to fluorine because fluorine is more electronegative element, it attracts electron towards itself. Therefore here F becomes F minus and Cl becomes Cl plus. Therefore fluorine does not act as a central metal in any interhalogen compound. So look at the example of any interhalogen compound in which fluorine is always not act as a central metal ion or central metal atom. So that is the second characteristic property of interhalogen compounds. And third one. So third property is in interhalogen compounds, highest electronegativity electronegative element is always written at left hand side, So look at the same example, ClF. So here it is, highest electronegativity element is always written at right hand side, ClF. So look at the example. So here chlorine is having nearly 3.0 electronegativity, whereas fluorine having electronegativity 4.0. So highest electronegative element, that is fluorine, is always written at right hand side, and lowest electronegativity element is always written at left hand side. So this is the third property. And fourth one is naming of interhalogen compound, IHC, interhalogen compound. So the naming of interhalogen compound always follows left hand side element. That is, if suppose in the case of ClF or BRF5 or IF5 or IF7, so this is a interhalogen in which, so first one is no interhalogen contains more than 2 halogens. So here it contains only bromine and fluorine. So here iodine and fluorine. So all are containing only 2 halogens. So that is the first point. And second one, fluorine does not act as a central metal. So here central metal is bromine. So in this case central metal is iodine. And also third one, highest electronegative element is always written at right hand side. So fluorine is having highest, that is written at right hand side. Similarly in the case of IF7, so it is written at right hand side. And now naming. So naming of interhalogen compounds follows left hand side element first, that is here bromine. So this is named as bromine pentafluoride. So there are 5 fluorine atoms, that is why this is referred as pentafluoride. And similarly here iodine with 7 fluorine, so it is iodine hexafluoride. This is named as iodine hexafluoride. If suppose it is ICl3. So what is the name of ICl3? So first follows left hand side element, that is iodine. So this is iodine trichloride. So there are 3 chlorine atoms, that is why this is referred as like this, iodine trichloride. So the naming of interhalogen compound follows left hand side element starting first, that is iodine and 3 chlorine atoms. So this is the fourth property of interhalogen compounds. And now fifth property. So in fifth property, AX and AX3 type, both are interhalogen compounds. These are always formed due to less electronegativity difference elements. Less electronegativity difference halogens. So look at the examples. So CLF, BRF, BRCL. So these are the examples for AX type, and also CLF3, BRF3. So here electronegativity difference fluorine and chlorine is less than 1. This is 4 and this is nearly 3.1 like that. So it is always the difference between electronegativity of fluorine and chlorine is always less than 1. Here also less than 1, less than 1, less than 1. So that means if the electronegativity difference between two halogen atom is less than 1, then it should form either AX type or AX3 type interhalogen. Whereas remaining two cases, that is AX5 or AX7. So these are the interhalogens which are formed due to, so there is a large electronegativity difference. Large electronegativity difference between the halogens. If suppose IF7 or IF5 or BRF5. So in this case, iodine is nearly having 2.0 or 2.4 up to 2.5 electronegativity, whereas fluorine having 4.0 electronegativity. So there is a large electronegativity difference. It is greater than 1. So it is nearly 1.5. So as the electronegativity difference increases, then halogens forms either AX5 type or AX7 type interhalogens. So only two reasons. If suppose there is a small electronegativity difference between the halogens, then it forms either AX type or AX3 type. Whereas if there is a large electronegativity difference between the halogens, then it forms either AX5 or AX7 type interhalogens. So this is the fifth characteristic property of interhalogens. Next property. So next property is fluorine forms maximum number of interhalogen compounds. Maximum number of interhalogen compounds. So look at the examples. So CLF, BRF, CLF3, BRF3, IF5, IF7. So in all these interhalogen compounds, so there is a fluorine atom. Therefore, fluorine forms a maximum number of interhalogen compounds than remaining halogens. So the reason for this is fluorine is more reactive. Its reactivity is more. Why it is having highest reactivity? That is again the reason. It is having highest electronegativity as well as a small size. Fluorine having highest electronegativity, at the same time it is small in size. Small size. So these are the reasons for fluorine having high reactive. That is why fluorine forms a maximum number of interhalogen compounds. So this is the next property. And last property for interhalogen compounds is fluorine does not form interhalogen compounds with coordination number beyond 4. So in the interhalogen compounds, fluorine always forms a compound in which the coordination number should be less than 4. So after 4, it does not form any interhalogen compound. So all these are important characteristic properties of interhalogen compounds. So now preparation. So what is the preparation of interhalogen compounds? Preparations. So interhalogen compounds are prepared directly from halogens. Directly from halogens. So directly from halogen means mixing of any two halogens, it directly gives a interhalogen compound. If suppose for the preparation of IF7, so it is the reaction with F2 plus, if it is Cl2. So fluorine with Cl2 gives 2ClF. So this is a interhalogen compound and it is prepared directly by the mixing of fluorine gas with Cl2 gas. So whenever F2 plus Cl2 react with each other, it gives 2ClF. And if suppose Cl2 plus 3Br2, then it gives 2ClBr3. It gives BrCl3. So here 3 moles and 2 moles. So it is a ClBr3. So AX3 type interhalogen. So similarly, different interhalogens are prepared directly by the reaction between the halogens. So write there are different reactions. If suppose I2 plus Cl2, it gives 2ICl. Similarly, I2 plus so if it is 5 moles of iodine fluorine, then it is reacted with 5 moles of F2. So I2 plus 5F2, it gives 2IF5. So this is the balanced equation. So there are 5 moles of fluorine reacted with 1 mole of I2, it gives 2IF5. So this is a AX5 type interhalogen. AX5 type interhalogen. So similarly, I2 plus Cl2 or Br2 gives IBr, 2 moles of IBr. And for the preparation of IF7 type, so F2 plus 7I gives 2IF7. So this is I2, 1 mole and 7 moles of fluorine. Then it gives a IF7 type interhalogen compound. So all these are prepared directly by mixing of one halogen with another halogen. If you want to prepare ICl, it is reacted with iodine gas with chlorine gas. If you want to prepare IBr, it is reacted with I2 with Br2. So similarly, for any interhalogen compound, that is prepared directly from mixing of two any interhalogen compounds. So all these are preparation methods for interhalogen compounds. Now, physical properties. Physical properties of interhalogen compounds. So what are the physical properties? So first one. So interhalogen compounds are volatile in nature. All are volatile. So volatile means these are easily dissociated into its ions, that is nothing but all these are having high reactive. All are having high reactive compared to halogens. But only one exception case, that is except fluorine. Fluorine is more reactive than all halogens as well as all interhalogens. So the reason for high reactivity is having highest electronegativity. Except fluorine, remaining interhalogen compounds are more reactive compared to halogen compounds. So if suppose ICl, so ICl reactivity is more compared to Cl2 gas. So this is a halogen and this is interhalogen. So here the reactivity of ICl is more compared to Cl2. Why? What is the reason? So again look at the bond strength. So here there is a bond between iodine and chlorine, whereas in the case of Cl2 there is a bond between same atoms, that is chlorine atoms. So here chlorine is more electronegative, this is also more electronegative, that is why these are always attracted towards each other. Therefore this bond is very strengthened. So this is a strong bond. There is a strong bond between two Cl atoms because both are electronegative and also both are same atoms. So it attracts electron towards itself. Again this chlorine attracts towards itself. Therefore this bond strength is very high. So as the bond strength increases, its stability is also increases. Therefore it is more stable. So more stable means it is less reactive. This is less reactive. Therefore, Cl2 molecule is having a strong bond between two chlorine atoms. That is why it is more stable and hence it is less reactive. Whereas ICl, so here there is a electronegativity difference between chlorine and iodine. So it is having nearly 2.5 and this is having 3.0. So here chlorine is more electronegative than iodine. Therefore chlorine attracts electron towards itself. That is Cl becomes Cl minus and I becomes I plus. So due to formation of ions or due to electronegativity difference, this bond is a weak bond. So it is easily breakable. So this bond between iodine and chlorine is weak. So weak bond means it is less stable. Therefore ICl is less stable. Less stable means it is high reactive or more reactive. So this is the reason for high reactivity of a interhalogen compounds compared to halogens. In halogens there exists a strong bond between same halogens. Whereas in the case of interhalogen compounds, there is a weak bond between two different halogens. Both are having different electronegativity. So as the electronegativity difference increases, then that bond is very weak bond. Hence it is less stable. That means it is more reactive. Therefore, consider the examples of Consider the examples of ICl, IBr and IF. This is also interhalogen compound. So iodine with fluorine. So here there is a large electronegativity difference iodine and fluorine. Hence this is very weak bond between fluorine and iodine. Hence it is very less stable. Less stable. It means it is more reactive. So compared to IF, IBr, so here it is 2.0 electronegativity, 2.5 and this is nearly 2.8. So here it is 2.5 and 4. So compared to IF, IBr having a small electronegativity difference between iodine and bromine. So its bond is somewhat stable compared to IF. Therefore, this is less reactive compared to IF. So in this case, again there is a difference between I and Cl. So here it is 2.5 and this is 3.0. So here bond electronegativity difference is 0.5. Therefore, compared to IBr, it is more reactive. Whereas compared to IF, it is less reactive. Therefore, the order of arranging interhalogens. So IF is always having more reactive and then ICl and finally IBr. So this is the reactivity order. Reactivity order. So the final conclusion is, if there is a large electronegativity difference between two halogens present in a interhalogen compound, then it is more reactive. So here IF, there is a large electronegativity difference between iodine and fluorine. Therefore, it is more reactive. If the electronegativity difference between two halogens in a interhalogen compound is less, then it is less reactive. So, reactivity is basing on electronegativity difference. So, final conclusion, reactivity of interhalogen compound is depends on electronegativity difference. Electronegativity difference. So this is the physical property of interhalogen compounds. So next one is solubility. Solubility of interhalogen compounds. So look at the example of ClF. So in this case, Cl is having more electronegativity, that means it is having negative sign and this is positive sign. But here both are halogen compounds, both are having highest electronegativity. Therefore, here there is a existing of covalent bond takes place between the halogens, because halogens are more electronegativity elements, so there is a bond takes place between halogens, that is due to sharing of electrons. That is due to sharing of electrons. So that is why all interhalogen compounds are covalent bond in nature, that is all are covalent in nature. So that is due to high electronegativity of halogens, and also this is a polar compound. So what is polar? So Cl plus as well as F minus. So it becomes ionic nature, fluoride ion as well as chlorine ion. So it is polar, that is negative charge as well as positively charged ion. Therefore, a polar compound is always soluble in polar compound, that is nothing but water. So water is a polar compound. Why? So in water there are H plus ion as well as OH minus ion. So it is easily dissociated into its ions, that is why this is polar. Here ClF, this is a polar compound, therefore it is soluble in a polar solvent, that is nothing but water. So ClF, it is soluble in water. Therefore, interhalogen compounds all are polar in nature, therefore all are completely soluble in water, because this is also polar. Whereas interhalogen compound does not soluble in organic solvents like esters, ethers, alcohols, like that. So these are non-polar. That is why a polar interhalogen compound does not soluble in a non-polar organic solvents, alcohols, ethers, esters and so on. So this is the solubility of interhalogen compounds. So finally, in this question we required the structures of interhalogen compounds. So what is the structure of AX type interhalogen and AX7 and also AX5 and finally AX7? So in our afternoon class we discussed about the structures of all these interhalogen compounds. So how many bonds are present in that interhalogen and how many lone pair of electrons present in interhalogen compounds. So due to presence of lone pairs, the structure is maybe deviate from its original structure. So that is why, so structure of every compound is important and it is discussed in the afternoon class. So stop here today and discuss the structures in the next class. Thank you.